Hi engineers! Have you ever wondered if two words are secretly twins wearing different outfits? In the world of coding interviews, we call this checking if strings are isomorphic. Today, I'm going to show you exactly how to build a modern JavaScript solution for this puzzle, and then we will tackle a second similar challenge called word pattern. Mastering these two will give you a massive edge in your next technical screening. We start with a question. What is an isomorphic string? Before we start typing, let's break this down in plain English. Imagine you have a secret code where every letter in one word must consistently turn into one specific letter in another word. Take the words egg and ad. These are isomorphic because E always becomes A and G always becomes D. However, foo and bar are not isomorphic. Why? Because the first O in foo maps to A, but the second O cannot suddenly change its mind and map to R. It is a one-to-one relationship. One letter gets one partner, and that partner cannot be shared with anyone else. Now, step-by-step coding solution. Isomorphic strings. Let's get our hands on the keyboard and build our first solution. First, we define our logic by creating a constant named isomorphic. We set this equal to an arrow function that takes two inputs, which we will name S and T. The very first thing we should do inside our function is a quick safety check. We write an if statement to see if the length of S is not equal to the length of T. If the words are different sizes, they cannot be isomorphic, so we immediately return false. Now, we need to remember the relationships between the letters. We create a constant named map, S, and set it to a new map object. Right below that, we create another constant named map, T, and set it to another new map object. Next, we walk through every character. We start a for loop. We initialize a variable using let I at 0, and we let it run for the length of the string S. Inside the loop, we create a constant called char S and set it to the character at index I of our first string. Then, we create a constant called char T and set it to the character at index I of our second string. Now for the logic check. We write an if statement to check. Does map S already have a record for char S? And if so, is the character it is linked to different from our current char T? If that is true, we return false. We do the same for the other direction. We check if map T already has a record for char T, and if that record is not our current char S. If there is a mismatch, we return false. If we pass those checks, we save the relationship using the set method on both maps. Finally, if the loop finishes, we return true. Now that we have finished building our first algorithm, let's verify it works before we move on. We are going to write a console log and call our function isomorphic with the words paper and title. If you follow the logic, P consistently maps to T, A to I, and R to E. When we run this, the expected result should be true. Let's test the failing case too. We write another console log using the words foo and bar. When the code hits that second O, it will see that O is already supposed to be linked to A, not R. The expected result here should be false. Perfect. Our logic is solid. Now let's look at a very similar problem that often follows the first one in interviews. Word pattern. In this task, you are given a pattern like ABBA and a string of words like dog, cat, dog. The logic is the same. Does each letter in the pattern map to exactly one word in the string? Let's start coding this one from scratch. First, we create a constant named word pattern and set it to an arrow function. This function will take two arguments, the pattern and the string S. Inside the function, our first step is to transform that single string of words into something we can iterate through. We create a constant named words and set it to s.split. Inside the parentheses for split, we provide a string with a single space. This effectively chops our sentence into an array of individual words. Just like our previous solution, we must perform a length check. We write an if statement to see if the length of the pattern is not equal to the length of our new words array. If the number of characters in the pattern doesn't match the number of words, we return false immediately. Now, we need our memory storage. We create a constant named map pattern and set it to a new map object. Right below it, we create another constant named map words and set it to another new map object. This keeps our relationships organized. Next, we start our for loop. We initialize the counter with let I equals 0, and we let it run until it reaches the end of the pattern length. Inside the loop, let's define our current targets. We create a constant named char and set it to pattern at index I. Then, we create a constant named word and set it to the words array at index I. Now we perform our validation logic. We write an if statement to check if map pattern already has the current char. If it does, we check if the word it is linked to is not equal to our current word. If there is a mismatch, we return false. We do the same for the reverse. We write another if statement to check if map words already has the current word. If it does, we check if the character it is linked to is not equal to our current char. If that rule is broken, we return false. If we have made it past both checks, it means this is a valid pair. We use the set method on map pattern to link the char to the word. Then, we use the set method on map words to link that word back to the char. Finally, once the loop has finished checking every single element, we return true because we have a perfect pattern match. Time to test our second solution. We are going to write a console log and call word pattern, passing in the string ABBA as our pattern, and the sentence dog cat cat dog. When you run this, you can see that A maps to dog and B maps to cat consistently, so the result should be true. Now, let's test a failure. We write another console log with the same pattern ABBA, but this time we change the string to dog cat cat fish. When the code reaches the final index, it will see that the pattern letter A is already locked in with dog, so it cannot map to fish. The expected result here should be false. Everything is working exactly as it should. Interview tips for QAs and SDETs. When you are in a QA or SDET interview, these mapping problems are popular because they test your ability to handle data structures. First, notice we used const and let. This shows you understand modern JavaScript scope. Avoid var at all costs. Second, notice the split method in the second solution. As an SDET, you will constantly be parsing strings from log files or UI elements. So showing that you can manipulate strings into arrays is a huge green flag for interviewers. Finally, mention the big O complexity. Both solutions run in linear time, or O of n, because we only iterate through the data once. This is the gold standard for performance. That's it for today. We have covered 2 heavy-hitter interview questions using clean, modern JavaScript. If you found this helpful, make sure to subscribe to the channel to see more coding solutions and interview prep. Now, I want to hear from you. Drop in the comments your most recent interview coding algorithm, and we will solve it together in the next video. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow. At Code Crack Interviews.